this section, we're going to learn another way to use the chi-squared test. This time we're going to do a test for independence. Now the degrees of freedom this time will be rows minus 1 times columns minus 1. And to get the expected value, you do the row sum times the column sum divided by the grand total. So let's look at this first example. A researcher wishes to see if there's a relationship between the hospital and the number of patient infections. A sample of 3 hospitals was selected, and the number of infections for a specific year has been reported. The data are as shown. So we got hospitals A, B, and C. We're doing surgical site infections. Here's the observed values. Pneumonia infections, observed values at each hospital. Bloodstream infections, the observed values at each hospital. Now the last column is for totals. They don't always include the totals, you guys. So sometimes, let's just draw a line here. Sometimes they only give you the data and you have to do the totals yourself. So you would add all the way across to get these totals, and you would add all the way down each column to get those totals. And this number over here is called the grand total. Okay, so 582 would be the grand total. It says at alpha of 0.05, can it be concluded that the number of infections is related to the hospital where they occurred? Okay, so let's look at the next slide. So our null and our alternative can be the same for these, okay? So for the first one, you're saying they are independent, which means it doesn't matter what hospital you went to. That's the null. For the alternative, you're saying they are dependent. It does depend on what hospital you went to. Okay, now remember on this one, they were saying, is it related to the hospital? So that means the claim is they are dependent on the hospital. If they were independent, then it would not matter. So they are claiming dependent for step 1. For step 2, you look at the number of, and let's go back and show you this again, degrees of freedom is the number of rows minus 1 times columns minus 1. There are 3 rows and there are 3 columns. You don't count the totals, okay? So I have 3 rows. 3 minus 1 is 2. Okay, I have 3 columns. 3 minus 1 is 2. 2 times 2 is 4. So we have 4 degrees of freedom. You look at your chi-squared and you go down 4 degrees of freedom. Alpha is 0.05, and you find your critical value is 9.488. So we went 0.05 across the top. We went 4 down at the on the side on the left, the degrees of freedom. And you get 9.488. This is a right-tailed test, so you put your critical value there. Now, before we do step 3, this one's the tough one. Before you do your test value, you have to get your expected values. So let me show you how that works on the previous slide. For 41, okay, that's my observed. To get my expected, and I'm going to put it out here in blue, or I typically would put it out here by the side. Okay, it's row sum times column sum divided by grand total. So to do 41, my row sum would be 119. My column sum would be 246. So I'm going to do 119 times 246 divided by 582. And that gives me 50.3. You just write it in parentheses to the side. Let's look at the next one. So for pneumonia, hospital A. So they observed 27. Expected would be 119 times 136 divided by 582. That gives me 27.81, and I put it there. Let's look at the next one. So for this one, the bloodstream infections was 51 is what they observed. Expected would be 119 times 200 divided by 582. So in parentheses out here, they put 40.89. Let's do one more. Let's do this one. Okay, let's do hospital B, surgical infections. So they observed 36. To get expected, you would do row sum, which is 79, times the column sum, which is 246, and then divide by 582 to get the grand total there. That gives you an expected value of 33.39. You would do the same for every one. Here, row sum is 79, column sum is 136, divided by 582 gives you 18.46. here. Row sum is 79. Column is 200. So 79 times 200 divided by 582 gives you 27.15. For this one, 384 times 246 divided by 582 is 162.31. For this one, 384 times 136 divided by 582 is 89.73. For this one, 384 divided by 200, or excuse me, 384 times 200 divided by 582 is 131.96. Those are all your expected values in parentheses. Now remember the chi-square test does observed minus expected squared divided by expected. So let me get a different color here. This would be step 3. We're getting our test value here. Okay, so our step 3 is our test value. So down here, for every single one, you're going to do observed minus expected squared divided by expected. So 41 minus 50.3 squared divided by 50.3. 27 minus 27.81 squared divided by 27.81. Then you're going to do 51 minus 40.89. Square that divided by 40.89 and so on. You're going to do this 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Add them up. And that gives you a test value of 30.698. Now that is greater than 9.488. So that would be over here. Now for step 4, we look at the white area. It is empty. When it is empty, we reject the null. So that's our step 4. For step 5, we got to go back to step 1 and see what they claimed. They claimed the shaded area, the alternative. Go to the shade and look for your evidence. It's there. So there is enough evidence to support the claim. It is dependent upon which hospital you go to as to how likely you are to get an infection.